Professor Bob Young back at you with this instructional video. We're going to look at some equations of inverses in this exciting episode. Now again, you can refer to your handout in your in Angel or the supplemental handouts that I'll give out at the start of the term. And I think we're going to kind of focus on this part right down here under the blue, finding an equation for the inverse where the function is 1-to-1. And I've got it 3 easy steps here, and we'll go through some as we progress. And there's the other part of the handout here that we'll talk about. Now, equations of inverses, by definition, the inverse of a 1-to-1 function is found by interchanging the x and y values of each of its ordered pairs. The equation of the inverse of a function defined by y equals f of x is found in the same way. And we looked at that in the last video. So there's that part on your handout that I gave you that will kind of help you as you're going through your homework and stuff. Step 1, interchange x and y whenever you've got a function that's 1-to-1 and you want to find its inverse. Step 2, solve the new equation for y and then write it in that new cool inverse notation. F minus 1 of x is the inverse of y notation. So let's first look at the example here. Decide whether each inverse defines a 1-to-1 function, and if so, find it. So we've got an equation here, y or f of x equals 2x plus 5, and we know this is the graph of a line, hopefully by now. And it's a non-horizontal line, so it's going to pass both the vertical and the horizontal line test, and it will be 1-to-1. So since we know it is 1-to-1, let's find its inverse. So step 1, we're going to write f of x is y, so we're going to make this y equals 2x plus 5. Step 2, notice we're going to interchange x and y, so y becomes x, x becomes y, and then we're going to solve this new equation for y. So we are going to go ahead here and we can subtract 5 from both sides here, which I'm going to do. So 2y, and then rewriting it, 2y equals x minus 5. Let's get the 2y on the left side of the equation here and make it a little bit easier. Divide both sides by 2. So our inverse would be, the inverse of f would be 1/2 x minus 5/2. And that's just taking the 2 and putting it underneath each fraction and making it look a little bit better here. All right, so in the function, the value of y is found by starting with a value of x, multiplying by 2, and adding 5. The first form of the equation of the inverse has us subtract 5 and then divide by 2. This shows how an inverse is used to undo what a function does to the variable x. I like that word, undoes, again. All right, now decide whether each equation defines a 1-to-1 function. Now let's look at this example, y equals x squared plus 2. Now if you think about that in our previous lessons, that is a parabola shifted 2 units up that looks like this. So I'm suspecting, wait a minute, that isn't going to pass the horizontal line test. So it says the equation here will fail the horizontal line test. For example, both x equals 3 and x equals -3, if we plug that in for x, will give us a y value of 11. So it is not 1-to-1 and does not have an inverse. So we can't find the equation of that. All right. Now, if we did not notice this, then the following steps, okay, let's say we didn't know that it didn't have an inverse. We could use the following steps, and some students will go, I'll show you, Young, I'll find an inverse for this, even though it's not 1-to-1. And they would interchange the x and y's here, so we'll do that just to show you. And then we would end up with y squared equals x minus 2, and then taking the square root of both sides here, we get y equals plus or minus the square root of x minus 2. Now, remember that plus or minus there from previous lessons. That may have torqued some of you in the past, but that tells me not 1-to-1. All right, so when that happens, it cannot have an inverse. All right, so I know you're saying, well, bummer, Young, let's do one that does have an inverse. I need more examples here, and you know Young will give you more examples, so let's try this one. Y equals x minus 2 cubed. Now, notice this is going to be our friend the S that shifted which direction, if you're thinking about this graph. I mean, and graphing can sometimes help you determine one-to-one. This would be a horizontal shift 2 units to the right. So I would expect a graph of an S to look something like this if we were to put values for X in and get Y. So notice this will pass both horizontal and vertical line test, and we'll have an inverse. So let's find that inverse. We'll go ahead and do the steps here. Replace f of x with y. Interchange them. X becomes y becomes x. And solve this new equation for y here. So we'll take the cube root of both sides to get y by itself. So we'll get the cube root of x equals y minus 2. We will add 2 to both sides. And here is our f inverse x notation. So the inverse of f of x is the cube root of x plus 2. All right, one way to graph the inverse of a function f, whose equation is known, is to find some ordered pairs that are on the graph of the function, and then interchange x and y to get the ordered pairs that are on the graph of the inverse, plot those points, and sketch the graph of the inverse through the points. A simpler way is to select points on the graph of the function and use symmetry to find corresponding points on the graph of its inverse. For example, suppose the point AB shown here is on the graph of a one-to-one function f. Then the point BA is on the graph of its inverse. So the line segment containing AB and BA is perpendicular to and cut in half by the line y equals x. The points AB and BA are mirror images to each other with respect to that line y equals x. Now, if you think about this line y equals x, it will always split down the middle of any function and its inverse. And remember why, because when we did the algebraic test for inverses, when we put in and did FOG, we got x. And when we did GOF, put f in for g, we got x. So any inverse and a function will always reflect about this line y equals x and have symmetry about it. Thus, we can find the graph of the inverse from the graph of the function by locating the mirror image of each point in the function with respect to the line y equals x. So graphing an inverse here, in each set of axes, the graph of a one-to-one function f is shown in blue. We're going to go ahead and have some fun here, and we're going to graph the inverse in red. So the graphs of two functions are shown in blue here. We're going to see that coming up. Their inverses are shown in red. Now notice in each case when we get there, the graph of the inverse is a reflection of the graph of the function with respect to that line y equals x. And there it is. Notice that line y equals x here splits it right down the middle. So given any function, you can kind of reflect about that line and you can graph its inverse. And notice both of these blue lines, or blue graphs, there's two of them here, are one-to-one because they pass both vertical and horizontal line tests and therefore have an inverse. All right, now let's go ahead on this one. We're given one more example. Y is the square root of x plus 5. Let's find the inverse. Now here you got to be a little careful. First, notice that the domain of the function is restricted to the interval -5 to infinity. So we have to choose x values here. And if you think about making a little chart here, we can. This is going to be one of those that's going to shift 5 units to the left. So if we put -5 in for x, we'll get the square root of 0, which is 0. So we have to pick values greater than -5. See, because if we put -6 in here for x, we're going to have the square root of a negative, and we don't want to go there. All right. So since this function is one-to-one, it's going to be increasing on its entire domain. It will have an inverse, and we'll go ahead and find it. So here we go again with our steps. We're going to change f of x to y. We're going to, and then notice here we're saying that, hey, we got to be careful. X has to be greater than or equal to -5. When we interchange them, notice now y must be greater than or equal to -5. We'll square both sides of the equation to get rid of that square root. Something we've learned in previous lessons will help us here. And solving for y here, we're going to get y equals x squared minus 5. Now, we maybe should have shown an extra step in here. So when we square both sides, here's what we'll get. And then to get y, we'll subtract 5 from both sides, and there it is. However, we cannot define the inverse as x squared minus 5 because the domain of the function, remember, was -5 to infinity, and its range is 0 to infinity. The graph of f is the domain of the inverse, so the inverse function must be defined as follows. If we're going to say that the inverse is x squared minus 5, x must be greater than or equal to 0. And again, if you plot some points, you're going to see this. So as a check, the range of the inverse, -5 to infinity, is the domain of f. So graphs of the function and its inverse are shown. The line y equals x is included on the graphs to show that the graphs are mirror images with respect to this line. And then we even showed you how to kind of look at it on the graphing calculator as well. They put a little graphing calculator image in there for those of you with the graphing calculators. So in review, some important facts about inverses, and this is going to sum it all up here, the last few videos. If a function is one-to-one, then its inverse exists, f minus 1, or f inverse exists. The domain of f is the range of its inverse, and the range of the function is the domain of its inverse. And if a point AB lies on the graph of the function, then BA lies on its inverse. So the graphs of f and its inverse are reflections of each other across that line y equals x. And to find the equation for the inverse, replace f of x with y, interchange them, and solve the new equation for y. And this gives us the inverse of the function. Well, that is one-to-one. All right, hit that homework. Professor Bob Young signing off. Have a good one.